In this video, you'll be introduced to the idea of using similar polygons in order to solve problems. The first thing that I want to introduce you to is this new symbol. That squiggle means the word similar. So just as though we have a symbol meaning congruent, we also have a symbol for similar. We say that two figures are similar when they have the same shape, or in other words, the same angle measure, but not necessarily the same size. The corresponding angles are congruent, which is what gives our figures the same basic shape, and the lengths of the corresponding sides are always proportional. In the first example, we're given these two similar quadrilaterals, and just as when we wrote a congruency statement for triangles, we always matched up the corresponding parts, we also match up corresponding parts when we write the similarity statement. In this particular case, A is the first vertex named in the first quadrilateral, and it matches up or corresponds with vertex E in the second, so those would be our pairs of congruent angles. B matches up with F, and those angles would be congruent. Following that same pattern, C is going to correspond with G and be congruent. And then lastly, D will correspond to H and be congruent to one another. So as far as the pairs of congruent corresponding angles, angle DAB would be congruent to angle HEF. Angle ABC would be congruent to angle EFG. Angle BCD is congruent to its corresponding angle, angle FGH in the second quadrilateral. And then lastly, angle ADC is congruent to angle EHG. The proportional corresponding sides would be those that match up. And proportional means they have the same ratio. So if I compare the ratio for side AD to side EH, they would be exactly the same. And that would be the same as the ratio I would get if I were to compare the top sides, AB and EF, which would be the same as the ratio I would obtain by comparing the right sides of each quadrilateral, BC and FG, which would be identical to the ratio that would be observed if you were to compare the bottom sides, DC to HG. Notice that as I wrote each one of these ratios, I put in the numerator of my fraction the length of the large, or the side from the large quadrilateral, and in my denominator, I put the length of its corresponding side from the smaller quadrilateral. So every single one of these ratios compared the larger polygon to its corresponding side in the smaller polygon. It's important that when you write these ratios, you are consistent. So I put the larger in the numerator for each ratio, the smaller corresponding side in the denominator for each ratio. And that whole idea of being consistent is going to be very important as you proceed through and work through these problems, both in this video and in the practice that's associated with this unit. If I put the larger over the smaller in the first ratio, I need to continue that same pattern. I can't write this next ratio with the smaller polygon on top of its corresponding side in the larger polygon. All right, the next thing I'm going to do is slightly unusual because we don't do it very often, is I'm going to go ahead and I'm going to cross off that next sentence because it is just plain flat out wrong. So I want you to take a pen or pencil and completely obliterate that sentence. It's completely incorrect. But the sentence that talks about the ratio between the lengths of the corresponding sides being the scale factor, that's important to know. And sometimes another name that we might use for the scale factor, or another way you might see this, is written the constant of proportionality. So when they talk constant of proportionality, they're really talking about the scale factor. I'm going to go ahead and jump over example 2 because it's a terrible question and move right on to number 3. Number 3 says the sides of a quadrilateral have those lengths. Find the lengths of the sides of a larger similar quadrilateral if the constant of proportionality is 2 to 5. And again, as soon as I see constant of proportionality, I'm thinking in the back of my mind that what that really is the scale factor. They don't give me a picture, so I'm going to go ahead and set one up. Just to keep things simple, this is a quadrilateral, so I'm going to set this up kind of like a rectangle. And I've got a big rectangle and a little rectangle. And it says these guys are the lengths of the first one, and we're trying to find the lengths of the larger one. So the one I know is 8, 10, 12, and 15. And I know this is a really cruddy, crappy picture, but I'm going to say that I'm going to set this up so that my left corners are the congruent angles, my right corners are the congruent angles, so on and so forth. So I'm trying to find the corresponding sides in this second quadrilateral. I'm going to call them, for lack of something better, A, B, C, and D. So the top side in my larger quadrilateral corresponds to the top side in the right quadrilateral. Left side, right side in the larger quadrilateral corresponds to the right side in the smaller, so on and so forth. What's important is when I set this up is that I compare the corresponding pieces. I've drawn the picture in such a way that side A matches up with the side length of 8 in the second quadrilateral. So I'm going to go ahead and write a proportion. I'm going to compare A to 8. Keep in mind that this is my larger quadrilateral, this is my smaller. So when I go to use that scale factor, I'm going to have to write it as 5 over 2, such that I'm always comparing large to small. And again, I can't write this first ratio that compares large to small and then use the constant of proportionality or the scale factor in such a way that it compares small to large. And that's why I took and I reversed that constant of proportionality or that scale factor. Now I'm going to go ahead and simply cross multiply. So 2a is equal to 40 and each a is equal to 20. So the first side in the second quadrilateral is 20. And I'm going to go ahead and I'm going to do the same thing. This time maybe I'll compare 10 to B, but now I'm comparing smaller to large. So when I go to write my scale factor, instead of writing 5 over 2, which would be large to small, I'm going to write 2 over 5. So again, it really doesn't matter in which order you write the scale factor, as long as if I'm writing the scale factor small to large, I'm also comparing the quadrilaterals, the length of the small side to that of its corresponding side in the larger quadrilateral. So cross multiplication here gives me 2b is equal to 50, and b, or the length of that side, would be 25. Proceeding on in a similar fashion, I could go ahead and find C and D, but in the interest of being respectful towards your time, I'm going to skip the last two problems in that section so that we can go ahead and take a look at number 4, which is really the creme de la creme, or the really good, beefy, meaty, chewy question. So it says in the diagram below, we're given these two similar triangles. We're given some side lengths, which I'm going to go ahead and I'm going to label in my triangles. And they're asking us to find the length of CD. So I'm going to go ahead and label CD right off the bat with an X. The distance between points R and D is 4. Distance between points R and O is 6. And the distance between points O and H is 4. And again, I'm working with these two similar triangles. Well, the big triangle, where the first triangle is very simply the big one, the second triangle is much smaller, but what I really want you to take notice of is that C in the first triangle partners up or corresponds with angle O in the smaller triangle. And notice that C is the top angle in the big triangle, but O is not the top angle in the little triangle. So that tells me that before I can do anything else, I need to redraw these in such a way that their corresponding angles are matched up. So So I'm going to keep the big triangle the same, CHR. I'm going to draw his little counterpart in such a way that the top angles match up, the left angles match up, and the angles on the right, you guessed it, they match up. So as far as the vertices or the names for these points, recall that vertex C in the first triangle matched up with vertex O in the second, so that is point O. H corresponds to D, so there's H. His corresponding buddy over here is going to be D. And if I go back to that similarity statement, R should match up and correspond with itself. So it's that similarity statement that really determines how I label that second triangle. All right, so now if I go label some side lengths, C to R is x plus 4, H to R is 10, O to R from the picture is 6, and D to R is 4. And this was important because I've now oriented these triangles in such a way that their corresponding sides match up. I can go ahead and compare the x plus 4 in the larger triangle to its corresponding side 6 in the smaller. And again, be consistent. If I'm comparing the large side to its corresponding side in the smaller, then I've got to go ahead and I've got to compare large to small. So 10 to 4. So this large to small is what determines the order in which I compare these two. I could have written 6 over x plus 4 is equal to 4 over 10. That would have compared the smaller sides to, or the smaller triangle to the larger. That would have done just nicely. Whichever way you choose, you have to be consistent when you write that proportion. So I'm going to go ahead and I'm going to cross multiply. So going in one direction, I've got 4 times the quantity x plus 4 equals 60, or in other words, 4x's plus 16 equals 60. 4x is equal 44, and each x equals 11. At this point, I'm going to go back and look at what they wanted me to find. They wanted me to find the length of CD. And just be very, very, very careful. Make sure that whatever you do, you answer the question. So if I go back to the picture and I look for the length of CD, it does look as though CD is the piece that I've labeled with an X. So I'm just going to make sure I answer the question. The length of segment CD is 11. Excellent. Up at the top of the next page, I do want you to take a minute and think about the key ideas and the important takeaways. But when you get to question 2 in the question 1 in the check your understanding, I want you to completely skip that one, the one where it says determine whether or not the polygons are similar. Skip right over number 1, and then you can do the smile in today question, and you can do the last question in that section.